Are you someone preparing for data science interviews and want to land a dream job? This is the right place. This is the video that you must watch end to end to prepare yourself better for real world interviews. I'm Manjunath. Welcome back to Data Science Galaxy. Let's dive in. Here is the context. I'm going to show you exactly two scenarios. In fact, I'm going to show you the Python implementation of these two scenarios as well. So let me just briefly talk about the context. Scenario one is all about a model without feature engineering, and there are questions accompanied after that. Scenario two would be a model with feature engineering, and there are more questions accompanied with that scenario. So here is all you have to do. It is a simple ask from my side. Make sure you watch this video without missing even a single second. When I say this with a lot of responsibility. The questions that I ask after the end of each of these scenarios would prep you well for real world interviews. I'm sure you will all come out with the flying colors. Look forward to seeing answers to those interesting questions that I'm going to ask you off. So without much ado, let me go to the code itself and then talk about the scenarios. So here is the scenario one that I alluded to, which is again implemented in Python for demonstration. So what I've done is taken this sample dataset called titanic.csv, and probably it is worth going to the dataset first, isn't it? Let's go to the dataset. So this is the dataset that I'm going to look at for implementation for feature engineering, and I have questions associated with feature engineering. Motivation is not the code walkthrough. I'm going to do a deep dive of the code walkthrough and for feature engineering in my upcoming video. But the motivation here is to prep you well for your interviews so that you will give yourself a best chance of making it through for a dream job. So coming back to the dataset. So you can see here, it is popular dataset called Titanic, used for teaching classification problems, like for example, binary classification, where you could see survived 0 is not survived, survived category 1 is survived. So I'm not interested in training this further. I'm assuming that most of you are quite familiar with this dataset. So what I've done is, I've got two scenarios of implementation around this dataset. The scenario one that I alluded to already is importing the dataset, and I've not done anything fancy. No tips, no tricks. Plain vanilla implementation of the raw data and looking at the baseline version of the performance of this model. And the model built is random forest classifier to classify somebody survives or not. All I'm going to do is to execute this line of code and then show you the model performance. Let's see, give it time for the code to process. Okay, it's taking a bit more time. Yes, 79.72%. 79.72% is the performance accuracy without feature engineering. You all can see the implementation. But like I said, where are those questions, you must be wondering, right? Here are the questions. Think of it this way. I'm going to help you with a little more input. Look at this line of code. So what does this tell you? It is all about unpacking the original data set, raw data set, into train and test subsets. So what I've done, 80% of the random data of the original data set is unpacked into training data set, and therefore the remaining 20% is test data set. And also notice random state is 111. It could be any number. I've chosen to use 111. Then I have instantiated the random forest classifier and again pass the same random state of 111. So two things to remember. Random state 111 and 80% testing, 80% training and 20% testing. And the performance accuracy on the test data set is 79.72. And mind you, this is the first scenario that I alluded to, which is without feature engineering. Okay. Now let's quickly look at the second implementation, where we have the feature engineering taken care with some data pre-processing. So again, I have taken exactly 80% of the original data set into training and remaining 20% into testing, and random state kept exactly the same at 111. Mind you, this is with feature engineering and a bit of data pre-processing. Notice here I'm building the same random forest classifier model with the same random state set to 111. And let's look at the performance accuracy of this model. Give it time. I think it's still processing. Yes, 82.12%. Let's go back to scenario one. 79.72% without feature engineering, and 82.12% with feature engineering, close to 3% improvement. You would all expect feature engineering to be able to enhance the performance of the model, and that's where you do feature engineering, isn't it? So now, justification of employing feature engineering for model-based performance can be looked at, and you can easily interpret as to why feature engineering enhanced. But that's not the motivation yet. I'm going to make some tweaks. Here is the interesting piece. So from here onwards, don't miss out even a single second. I'm going to make some tweaks live right in front of you. No tricks, nothing. Simple tweaks to the code. Okay? I'll go back to the first scenario and make this split into 25% testing and therefore 75% training. And keep everything intact, including the random state, and the same model is being, but with 75% training data set. Let's go ahead and run this. 82.58% is the performance accuracy without feature engineering on 75% training data. So I shall do exactly same tweak here also, make it 75% training and 25% testing. But the second one is with feature engineering and data preprocessing. I want to just run this, see what happens. 82.51% after tweaking it on the test data for the performance, which is with feature engineering. Go back to the first one. 82.58% without feature engineering with 75% of training data. And the second is 75% of the training data with the feature engineering and data preprocessing. We have 82.51%. So what you notice is something counterintuitive. 82.58 without preprocessing and without feature engineering, and marginally less after feature engineering, 82.51. Let's just take this and copy to the other notebook so that you can see. This is without feature engineering and without much of preprocessing. This is with the feature engineering and a lot of preprocessing. Okay, so see here, when you don't do anything, model performance is better because it's 82.58, and with feature engineering, model performance is marginally diminishing. Now it is counterintuitive. So here is the interview question. Just by changing the sample size, how does model become slightly worse? Okay, I'm using the word in a loose sense. It's not that bad. Slightly worse, as it is marginally below the performance of that of the first model. Second, does feature engineering add any further value? More importantly, to achieve the second one to this level of performance, first thing is to say the performance is compared to the other is less marginally. Second is to say this requires extra time and effort in terms of both effort required to write additional lines of code, effort required to pre-process, and the cost of not just the computation, cost of time spent. So how do you justify feature engineering and data processing in the second scenario where you are getting performance marginally less to that of the first model where you got slightly marginally improved performance? There is no right or wrong answers. I'm looking for some interesting thoughts in the comment section as your justification. All I want to do is simply this. Let me rephrase the answer a little more succinctly. How do you justify in the second case the marginal decrease in performance after you applied feature engineering and data preprocessing? Whereas in the first case, none of it was required, but even then the model was marginally better. So can you justify feature engineering? Are we to say feature engineering does not add value? What is that is different that I've done as compared to the scenario one that I talked about in the second scenario of tweaking it to 25% of test data? So does that training and test data samples really matter over and above feature engineering, or what is that going on here? Something interesting is happening in this implementation of Titanic dataset with random forest classifier. So I want you to bring to bear all your interesting, creative, thoughtful justifications and rationale as to what is going on in the second instance when I change it from 80% training to 75%, or increased from 20% testing to 25% testing. So what's going on here? So is it worth putting effort to do feature engineering or not? So think about it and let me know. And by the way, on another note, in an upcoming video, I'm going to go through every line of the code walkthrough and make sure you hit the nail on the head, so to speak, for feature engineering. Go ahead and answer. If I tell you, okay, I've used 3 features as engineered features here, how do you even know 3 features to be done? How do you even know how many features are required? How do you even know feature engineering is going to justify? Because in this case, feature engineering is not justifying the effort. So these are some pertinent questions that I see big gap even with seasoned professionals in the industry. So if you are interested to understand feature engineering by going beyond the classic textbook definition and approach to feature engineering and transition to real world learning of what feature engineering is, and I'm going to reveal answers to some of the questions that I asked in this video. So with that thoughts, I'm hoping that you see some value in sharing videos and the content like this as a practitioner, okay, and as a mentor or a trainer, right? If you find really value in this, you know the rigor, right? Like, share and subscribe. And those of you who are sitting on the fence and not yet subscribed, what are you looking for? Please go ahead and subscribe, enable the notifications not to miss any upcoming video. So I'm looking forward to your interesting thoughts, views and justifications and rationale in the comment section. And if you have any additional question to ask, go ahead. I can incorporate some of those things in my upcoming video. Thank you so much for making it this far. Thanks for your time. Happy learning. Take care. Bye-bye. I'll see you next time.